Yes, welcome you to the general track of PyCon Sri Lanka, organized by Isaac in University of Mortua in collaboration with Matific Sri Lanka, where you are able to learn from the basics to advanced details about Python. Without further ado, let us move to our first session. Sorting is a basic function of any language. It is also a built-in function in most languages and so in Python. But to share with you the interesting facts behind the inbuilt function and show the magic methods for a better coding experience, let me welcome our first speaker on stage. Reuven is a full-time Python trainer. In a given year, he teaches courses at companies in the United States, Europe, Israel, India, and China, as well as to people around the world via his online courses. Reuven created one of the first 100 websites in the world just after graduating from MIT's Computer Science Department. He opened Lerner Consulting in 1995 and has been offering training services since 1996. So let me hand the mic to Mr. Reuven Lerner for this session. Over to you, sir.
Thanks so much. Hello, everyone. Good morning to you. It's morning here in Israel, a little bit earlier than for you folks in Sri Lanka. I'm super excited to be here and to be participating. I'm going to start my talk in just a few moments. I'm going to share my slides and everything. I love interactions. I love hearing from people. I love having people tell me let's sort of ask questions. So if I don't get to your question while I'm doing the talk, then please absolutely, I will get to it afterwards. I'm just going to play with my screen sharing now for a moment. So hold on a second. I'm going to put this here and put this here and put this here. Oh, I've got to gotta allow that. Screen, I think that's screen one. Yes, it is. Oh, you gotta be kidding me. I gotta. Okay, hold on just a second. I thought I'd already given these permissions. You know, folks, computers, they really don't like it when we surprise them. Let's try this, and we'll do that, and we'll do that. All right. So let me know if this somehow does not work when I share my screen. Is that sharing my entire screen? I don't think. Yeah, okay, looks good to me. Yay. All right. So let's even play this then. All right. So welcome to my talk, how to sort anything. And it looks like the way that my screen sharing is working, it's taking over all my displays. So I am going to look at questions at the end, and I'm sorry about that. But otherwise, I can't see what you're doing. And if the moderator wants to interrupt me with questions and comments, that is okay in my book. Do not feel embarrassed about that. So welcome to How to Sort Anything. Just a few words about myself. I teach Python. I've been in business, as you said earlier, I've been in business since 1995. I've been using Python for about 30 years now, along with some other languages. But about 10 or 15 years ago, I made the strategic decision to only do training and only do training in Python and things that are adjacent to Python, things like Git and machine learning. And so in addition to doing that, basically every day, I'm working with a different company around the world, teaching Python, everything from Python for non-programmers all the way up to advanced Python workshops and introductions to data science. I've written 2 books. One of them is Python Workout. The other one is Pandas Workout. The latter I am still working on, but I'm hoping to get done really soon, even the next week or 2 to get the first draft done. And I have a free weekly newsletter about Python. I get a new article about Python every week. It's called Better Developers. You can get it at betterdevelopersweekly.com. I believe I now have about 25,000 subscribers, which is quite amazing. But enough about me. Let's talk about our topic at hand, sorting. And sorting is really important. And I remember sitting in my university classes on algorithms, and we talked a ton about sorting. This is not that kind of talk. I'm not going to be talking to you about algorithms very much at all, which is what we talked about in my algorithms course, which was super crazy early in the morning, so much so that the professor and all the students complained. But who can we complain to? Sorting is one of these things that every developer needs to understand and needs to think about, because there's so many cases in which we want to sort data. Here are some examples of where we might want to sort. We might want to display data nicely, right? I want to do things from 1 to 10, first most important to least important, or least important to most important, by month, right, from January until December. So we want to display it. We want to display it alphabetically. Maybe make messy data slightly less messy. Just make it look a little more organized. We want to find the largest or smallest value in a collection. So how do we do that? We're going to sort, and then the first one, if it's an ascending sort, first one will be the smallest, and the last one will be the largest. We want to see which products, let's say we have a company, and we want to see which products sold best or worst in the last year. Well, we can do that too with sorting. We can look through different proposals and then figure out which supplier's proposal will cost us the most. Let's say I'm doing a mapping system. I can find out which gas station is closest to where I'm currently located. Maybe I'm running Netflix or a competitor to Netflix, and I want to show the user, I want to show my customer films that are similar to one that they just saw, right? You just watched the following. Maybe you want to watch something else. YouTube is famous, sometimes infamous, for doing that sort of thing. And in the same vein, maybe you're on Amazon or a similar sort of e-commerce site, and you are looking at a particular product, and it wants to show you other products that are similar to that. Well, let's rank the similarity, but then we've got to sort them, right, from most similar to least similar. And so sorting is something that we do just about every day. So how do we sort? Well, Python actually makes it really, really easy. If you have a list, and of course, a list is one of the built-in basic data structures in Python. If you have a list of integers, and here my list is 10, 5, minus 3, 7, minus 2, and 4. What I did here was I'm printing before my list is, and then I run the mylist.sort method. List objects in Python have a sort method. And so when I run sort, it actually changes the list. Now, just to sort of let you know also, this syntax is new-ish in Python. It's new as of Python 3.8. So it's already, like 2 years ago, 3 years ago. It's amazing. This syntax inside of an F string, you can, of course, put a variable name or any expression, and that will be printed back to you if you put it inside of curly braces. So I could have said my list inside curly braces, but here I say my list equals. And by putting that equal sign after the expression, I will then get the name of the expression. I'll get the actual expression equals in the value of the expression. You'll see that in just a moment. People are always curious about this, so I wanted to point it out. And so we see here, after I run this code, before my list is 10, 5, minus 3, 7, minus 2, 4, exactly what it was before. But afterwards, my list is minus 3, minus 2, 4, 5, 7, and 10. It is indeed sorted in ascending order. So seems great, right? And indeed, list.sort, the method sort on list objects, is pretty great. And let's like sort of summarize a few things. It's a list method, so it only works on lists. So if you want to sort a tuple, a string, sorting a string is kind of weird, but you can do it. You can't do it with list.sort. This is just on lists. It sorts from smallest to largest by default. And here is the most important thing. It changes the list object itself. That's crucial. And let's see an example of what that means here. So if I say my list equals 10, 5, minus 3, 7, minus 2, 4, okay? And then I say also my list equals my list. What do I have now? I have two variables, my list and also my list, that are both referring to exactly the same list. Two names, one data structure. So, and that's like super important to understand, right? We're not copying the list. We are having a new reference to the same list. So now what happens if I print before and then run my list sort and then print after? Well, we're going to see that before it's exactly the same thing. But after also my list has changed because I've not changed just my list, that variable. I've changed the list that my list and also my list refer to. All right, so if I run list.sort, I'm changing the list object, and anything that refers to it will also see that change. That's an important point to think about because lists are mutable. We're going to see an alternative to it in just a moment. Another thing to realize is that list.sort returns none. It's a rule of thumb that people are supposed to know in Python, but they do not. That if you run a method that modifies an object, then that method is supposed to return none. But yet I see people do this all the time. So we assign to my list, and then we say print before, and then they say my list equals my list.sort. And this line seems so natural. It seems like it should be a good thing to do. And Python won't give you any warning here. But here is before my list equals 10, 5, minus 3, 7, minus 2, 4. And after my list is none, right? And that's because, again, sort is a method that modifies the list. And the rule of thumb is that methods that modify the object should return none. And that's in no small part to avoid people from doing method chaining, where you'll have one method, another method, A dot B dot C dot D dot E, and oh wait, what happened back in B? So to avoid that sort of problem, Python discourages you from having methods that return the object itself. Instead, they should return none, and they'll have to break it up across multiple lines. But I see people make this mistake all the time with sort, mylist.sort, and also mylist.append. Oh my God, the number of times I see this is like very, very large. But we should not really use list.sort. I've shown it to you because otherwise you would ask me about it. But list.sort is probably a bad idea in many, many cases. A much better idea, a more modern approach is sorted. Now, sort, list.sort, is a method. It's a method that runs on list objects. Sorted is a function. There's no dot before its name. It's not connected to any particular class. It's a built-in function, so you don't need to import it. It's always available. And you can just say sorted. And it works with all iterables. Anything that knows how to run inside of a for loop knows how to work with sorted, at least in theory. All right, and it always returns a list sorted from lowest to highest and does not modify the source data at all. That is crucial. And that's why I can work with all iterables, including even with tuples. But I'm jumping ahead of myself. Let's talk about, or let's see what we can do with sorted. So how are we going to use it? Well, here's my list again. All right, I'm going to print sorted my list. Remember that my list here, right? So I'm going to print then my list afterwards. So what happens? Well, we get -3, -2, 4, 5, 7, 10. And after that, my list remains the same. My list is unchanged, right? So sorted is what I would call a more functional approach to sorting. It's not changing the data as list.sort does. It doesn't change the origin at all. It just returns a new value. So how are all these things being sorted? How is this being used? And what sort algorithm is being used? I'll mention a little bit this sort of thing from university CS classes. And people are like, oh, I know, we're using quicksort. We're using heap sort. We're using merge sort. Sometimes people will be funny and they'll say, we're using bubble sort, right? That's why Python is relatively slow, because it's bubble sort. No. It was invented by Tim Peters, and thus it is known as Tim sort. And Tim sort actually has been used in other languages. It's not a Python only thing, but people don't know that so much. And the idea in Tim sort is that real world data contains what they call natural runs, meaning there are always going to be small sections of the data that are already in order. So you don't need to assume that everything is completely randomized and everything needs to be sorted from scratch. And if we assume that there's some of these natural runs in our data, then maybe we don't need to sort of make the assumption always that things are completely out of order. So what happens is Tim sort merges runs. Tim sort merges these already in order sections. And if there aren't any runs, then it uses insertion sort to add them. So it's going to take this run and this run, this run, and it'll merge them together using merge sort. But if it has something that's not sorted, then it'll use insertion sort in order to get its job done. So it's a mix of these two different things. And apparently, I'm not a real expert in this sort of thing. Maybe I should have paid more attention to those university courses. But basically, it seems to work well with large objects, which is exactly what Python has a lot of. All right. Well, how does it really work, as it were? Well, behind the scenes, Tim sort does need to compare items. And it needs to know whether, if we have items A and B, like which is going to be true. Is A less than B? Is A greater than B? Or is A equal to B? And when merging or inserting, Tim sort is going to rely on this comparison. So if we have a sequence of numbers, like a list of numbers, a tuple of numbers, then we can just use less than, greater than, and equal. And we saw it earlier, right? Tim sort works just fine. The sorted function works just fine because it's able to use less than, greater than, equal on numbers. That works fine. What if I have a bunch of strings? Right? What if I have a bunch of strings and not a bunch of numbers? And so I can create a list of words. Here we go. This is a bunch of words, .split. Split, of course, is a string method that returns a list of strings. And that list of strings is now assigned to words. So can I run print sorted words? Can I sort them? The answer is absolutely, positively yes. A bunch is of this words. Python sorted them alphabetically from lowest to highest, meaning from earliest in the dictionary to latest in the dictionary. And it's not obvious to people how this works. So let's talk about it. So a one-character string, and remember that Python does not really have character objects. Python has strings, so even a one-character string is still a string. And a one-character string can be compared with less than. Now, how does it do this comparison? It's using the comparison, it's comparing based on the Unicode code point for the one-character string. Now, what do I mean by that? Well, back in my days, like old school, dinosaur times, we would talk about ASCII values. Each character had an ASCII value from 0 to 255. And then you would know which comes first. Well, Unicode says, let's not just do that for Latin characters in English. Let's do it for all characters for all languages around the world. And each character then in each of these languages in Unicode has a unique number. And so that number is what Python is using. That Unicode code point is what Python is using to compare. Now, it so happens that there's overlap with ASCII. So even dinosaurs like me who learned ASCII codes know, like, can apply that to Unicode here, at least in UTF-8. So we're going to compare those. So if I want to compare a one-character string, that's not so hard. I just compare the Unicode code point. What about comparing multi-character strings? Well, I first compare the characters at index 0. Okay, and does index 0 of word 1 come before index 0 of word 2? If so, then word 1 comes first. What about, well, if not, then does word 1, 0 come after word 2, 0? If so, then word 2 comes first. That's, not so bad. What if they're the same, though? Oh, if they're the same, then we're going to do the same thing with index 1. And then we'll try with index 2. And then we'll try with index 3. In other words, we're going to keep going until we find a character that breaks the tie, that tells us which of these strings comes first, or one of them ends earlier. If it ends earlier, then it comes earlier, or we find that they're the same, in which case it doesn't really matter. And actually, Tim's sort is what's known as a stable sort, meaning that it will not reorder things if they have the same order. So, oh, here we go. If they're equal, we'll return word 1. If one's a substring, the other return the shorter string. There we go. I should have paid attention to what was on my slides even. So if this sounds familiar, then that's good. Either you're a programmer or you've looked things up in a dictionary, right? It's not hard to imagine taking our dictionary algorithm, like how we look things up to find words there, and apply that here. We're looking at the first letter, then the second letter, then the third letter. If we are comparing words and figuring out which comes first, we look at the first letter, then the second letter, then the third letter. And so even though nowadays no one uses books, and even though nowadays even fewer people use dictionaries, I hope that all of you have at least a little bit of experience and you've used a version of this algorithm. But it turns out that this works on all Python sequences, a list of strings, or a list of lists, or a list of tuples. And that's because lists and tuples implement less than in the same way. So if I have a list of strings, we saw already, that's fine. A list of lists, I can compare them, and we're going to see that in just a moment. List of tuples, same thing. Well, wait, how do I compare lists? How's this working? Well, if I have list 1, 10, 20, 30, and list 2, 10, 20, 15, I can say, is list 1 less than list 2? That is going to be false. Well, how's it check? It's checking index 0, that's checking index 1, that's checking index 2. And list 1 is greater than list 2. Yeah, that's true. Well, what if I have a list comparing different types? Let's try to be really cruel here to Python and turn the screws a little bit. How will this work? Well, my list equals 20 BA 1030. What happens now when I say print sorted my list? And the answer is we get an error message. We get an error message because Python tells us less than is not supported between instances of str and int. Now, those of us who have been using Python for an awfully long time know that there was a time in Python 2 when this did work. You would get an answer. And that was not because somehow things were all turned into integers or all turned into strings. It was because Python first sorted by type and then sorted within each type. So you'd have all the strings and then all the integers, or was it all the integers and then all the strings? It really didn't matter. It was super confusing for people. Like, it seemed arbitrary because it was kind of arbitrary. So in Python 3, the powers that be that said, this is dumb, this is ridiculous, let's outlaw having lists of different types, having sequences of different types compared with this way. Now, you could, in theory, do it yourself, and we'll talk about key functions in a little bit, but don't do it. Don't do it. Besides, traditionally, remember that in Python, even though a list can contain objects of different types, traditionally lists are for sequences of the same type. Even though, as I like to say, the Python police are not going to arrest you if you create a list with the same type. What if I want to reverse the direction? What if I don't like this whole smallest to biggest thing? So if I say here, my list is 20, 30, 10, obviously a regular sort on it would give me 10, 20, 30. But I can pass the keyword parameter, keyword argument here, reverse equals true. And what that does is, you will not be surprised, it reverses the order in which things are displayed. And sure enough, we then get back 30, 20, 10. So now let's try to do something a little harder. What if I want to sort a list by words? Fine, we've done that already, but by their lengths. basically, I no longer want Tim's sort to be comparing word 1 is less than word 2. I don't want it to be doing that. I want it to be saying, is the len of word 1 less than the len of word 2? Now, some people, when they see this sort of question posed, they say, oh, I know what we're going to do. We'll use a list comprehension to turn all the words into their lengths. And then we will have a list of numbers. Then we sort the numbers. No. That's not what I want to do. I don't want to sort the lengths. I want to sort by the lengths. I want to sort the words and get the words in a new order by their lengths. It's sort of like if you have children in school, and I don't know if they do this where you grew up, but where I grew up, we sometimes would like all stand in line in order of birth date or stand in line in order of height. That was really cruel to the people who are not as tall. And so basically, we didn't want to sort the birth dates. We didn't want to sort the heights. We wanted to sort the children by the birth date or sort the children by the height. And that's what we want to do here. We want to sort the words by length. And it turns out that sorted supports this. If I have a function f, if I want to compare f of a is less than f of b, then I can call the sorted function with the keyword argument key equals f. Key is the parameter, and f is the argument, is the function we're going to pass. And so because I want to sort the words by length, we can call sorted with key equals len. Notice, I am not invoking len. There are no parentheses after len. There's no argument to len. I'm passing the function len as an argument to my function. This is something that's not unique to Python, but boy, oh boy, is it powerful and useful. So I can do that here. I can say words equals, this is a bunch of words that split. I say print sorted words, key equals len. And now look what I get. I get them in order of length. Okay, so that's great, but what can be a key function? And the answer is extraordinarily broad. A key function can be any function that takes one argument because it's going to be invoked repeatedly on all the elements of that list. It's going to be invoked on every element of that list, and it has to return a value that's comparable, that can be compared with less than. So if the function takes one argument, returns something like a number or a string or a list, that's fine. So for example, I can say sorted of words, key equals len. So I want to sort the elements of words by length. This is what we just saw. I can say sorted of numbers, key equals abs. Sort numbers by absolute value, again, from smallest to biggest, right? So it's going to ignore the minus sign on all those numbers. I can say sorted of words, key equals stir.lower. I can sort words ignoring the case. Why? Because the comparison will not be done on the words that are in the list words. Rather, they're going to be done on the result of invoking stir lower, lowercasing all the words. So if we're lowercasing all the words when we compare them, then it's basically a case-insensitive search. And notice that we can pass a method by passing as a class attribute, right? So lower is not a function. Lower is a method. But it's a method that we want to call on this word, then this word, then this word, then this word, then this word. So how can we do that? Well, we pass it as stir.lower, which is the method as defined on the class. It's a class attribute, and then it works just fine. Now, I mentioned already, but this is a key thing to remember. It's a common mistake to use parentheses after the key function's name. Don't do this. Sort of numbers, key equals abs, because what's going to happen there? Well, we're going to get an error message from Python. Python's going to say, wait, you're trying to run abs, but you're not giving it an argument. So it's not even going to run. What instead we're going to do is we're going to say sort of numbers, key equals abs. Here is the function I'm passing as an argument. We're passing a callable, and it's a function or a class, by the way. You can pass a class there, assuming the class takes one argument. Abs is a function, but the result is an int. But it's not going to work that way here. Okay. What if I have a list of lists or a list of tuples and I want to sort them by length? Well, I can just use key equals len, just like with strings. Because what's going to happen? Well, sorted is going to run len on each and every element of our list, the inner lists and the inner tuples. And then we're going to get a length back, and that's going to sort by that length. Fantastic. What if I want to sort by the sum of the numbers? So if I have a list of lists, and each inner list contains numbers. So I can say key equals sum, because what's going to happen? Well, sum is going to be run on each of the inner lists, or the inner tuples for that matter. And then based on that result, the inner lists are going to be sorted. Well, here's the thing. We can also pass our own functions to key. I can basically create a function, and so long as the function takes one argument, which will be one of the elements in what we're sorting, and the function return value is comparable. The function's return value is sortable. The function's return value is an integer or a string or something. then we're fine. And here is another key thing to understand. I keep using that phrase. The value that is returned by the function does not need to be the same type as the input, but we knew this already because the len function, it takes a string or a list or a tuple and returns an integer, but we were able to sort by len, right? So here's an example. I'm going to sort integers by the number of digits. A little weird, right? But okay, so I have numbers 500, 2,100, 130, 1,040. So I don't want to sort these numbers numerically. I want to sort them by the number of digits. So I can define a new function, define by digit count. All right, and so by digit count takes one argument. What is that argument going to be? It's going to be 500, then 2,000, then 100, then 1, then 30, then 1,000, 140. It's going to be invoked. Sorted is going to invoke it once per element. And what is going to be returned? Well, we're going to turn the number into a string. We're going to run stir on n, and then we're going to get the len of that string. And then I can say here, print sorted. And by the way, I'm using print so that it'll show up, but Python doesn't care. Print of sorted numbers, key equals by digit count. And this is, by the way, my sort of personal way of writing these key functions or calling them. I always name them by something something. It feels more natural to me. This is not a standard at all, although you're welcome to adopt it. But I say here sort of numbers. So I want to sort the elements of numbers, but I want to apply that function by digit count to each element before sorting. And what is the result I get? I get 1, 30, 40, 500, 100, 2,000, 1,000. You might be saying, wait. Something's wrong here. 500 comes before 100, and 2,000 comes before 1,000. Something is broken, but no. It's our understanding that's broken if we think that. Because basically, remember what I mentioned earlier in passing, that timsort is a stable sort. If two items in numbers have the same value, then they will be kept in their original order. So 500 came before 100 in our original list, and 2,000 came before 1,000 in our original list. And because by digit count returns the same value, the same result for 500 and 100, and for 2,000 and 1,000, so because it returns the same thing, they will remain in their original order. That's what it means to have a stable sort. Well, how about this? What if I want to sort sublists by their mean? So here I have numbers. Numbers is a list of lists. I have 4 sublists in there. And I want to calculate the mean of each list and then sort the inner list by that. Well, I can say def by mean of one list. And I can say return sum of one list, divide by len of one list. That's going to return a float because division in modern Python returns a float. And now I can say print of sorted numbers, key equals by mean. And I'm going to get 135. Then 10, 11, 10, 1, 1, 1, 5, 7, 3, 4, 2, 4, 6, 7. We don't see the means here, right? It's just a means to an end. Okay, fine. Anyway, sorry, I cracked myself up with dumb jokes. In any event, you see, though, that the mean is used to sort. Let's do something more sort of sophisticated. I'm going to sort by the number of vowels per word. So let's say I have words equals, this here is a fascinating, scintillating test. And I want to sort these words by the number of vowels in each word. Well, how am I going to do that? Well, I'm going to define a new function, def by vowel count. And you're starting to see that these key functions can be increasingly sophisticated. So def by vowel count takes one word. Remember, it's going to be invoked once per element in words. And then we're going to say print checking word. And you'll see why we're doing that printing there in a moment, right? But I think it's going to be useful to see what's happening there. Then we're going to say total equals 0 for one letter in word lower. If one letter in ARU, total plus equals 1, return total. So what's going to happen here? We're going to go through each word letter by letter by letter. If the current letter is an AIOU, if it's a vowel in English, then we're going to add 1 to total. And then we're going to return the number that we found. So I can now say print sorted of words, key equals by vowel count. And what's going to happen when I run this? Well, 2 things are going to happen. First of all, because the function itself is printing, we're going to get checking this, checking here, checking is, checking a, and on and on. Right? So it's going to check each of our words, check each of our strings, and it's going to print that. And this is a way for us to sort of convince ourselves that sorted is indeed running our key function once per element in our list. But we also get a return value, and this is a test here, fascinating, scintillating, by the number of vowels. We don't know the number of vowels. We didn't get that, but we did sort by the number of vowels. By the way, notice something additional here that people sometimes miss, that the word fascinating ends with a comma. Why? Because I split on white space. Whenever you split in Python without an argument, it splits on any white space. That's say space, tab, new line, carriage return, or my all-time favorite, vertical tab. So it'll split on any number of those in a row, but it's not splitting on comma. So comma ended up being part of our word. Not a bad thing. Doesn't affect our vowel count. If I were to sort by word length, then it would affect things. Okay, let's do other things. What about sorting file names by file length? So first of all, I'm going to get a bunch of file names. And how am I going to do that? Well, I am going to use glob. I love the glob module. The glob module is fantastic. It lets me get a list of files in a directory, or even multiple directories, by pattern. If you've ever done ls star or ls star.txt on the command line, or if you're using Windows, no, then you use like dir with star.txt, then you're using a form of not regular expressions, but globbing. I know it's a funny word, globbing. And so basically the glob module implements that. And then I'm going to use OS because the OS module has something called os.stat, which lets me find out the length of the size of a file. So I'm going to write my function here, def by file length, a file name. So this is my key function. And what's going to do? It's going to say return os.stat file name .st size. So what we're going to do is run os.stat on the file name, get a whole bunch of information back. And the only information we're really interested in is st_size, which is the size of the file. And then what I can do is say print sorted glob.glob of star.text key equals by file length. So what does this mean? It means go into the current directory, find all the files that end with .txt, and get a list of those strings, a list of those file names. Pass that list of strings to sorted, and then sorted will sort those strings not alphabetically, not by length, by file length. Why? Because it's going to run by file length on each file name. And sure enough, now we get them, and I can assure you that this is indeed the appropriate sorted length. These are from files I typically use in my corporate training classes. Let's now mix some things up together. What if I want to sort the file names by the file's vowel count? Well, I'm going to once again import glob. And now I'm going to say by vowel count, but now we're not going to do vowel count on a word. We're going to do file count on a file name. So how's that going to work? Well, I'm going to say total equals 0 for one line in open file name, meaning let's open up the file and go through it line by line. Then let's go through the line, which is a string, and we're going to lowercase it and go through one character at a time. And then if one character in ARU, total plus equals 1. So we're going to go through the file one line at a time, one character at a time, totaling the vowels. And this is how we can do it. I can say print sort of glob.glob star.txt key equals by vowel count. Once again, what are we doing here? So glob, the module, has a function glob. So glob.glob, I know it sounds funny, but that's part of why I like it. Glob.glob of star.txt. That gives me back a list of strings, list of file names ending with txt. I'm then going to pass that to sorted, that list is sorted, and I'm going to do key equals by vowel count. Our function will be invoked once per file, and we will then get a count of how many vowels are in each file, and the list of strings, the list of file names, will then be returned to us and displayed, thanks to print, returned to us with in increasing order, ascending order from smallest number of vowels to largest number of vowels. Very, very useful, I assure you. Okay, what's next? What if I have a list of dictionaries? And here I have myself and my children, admittedly from 2 years ago, so we've all aged a little bit. Sorry, but great. This is a time machine now. And so people here is a list of dictionaries, right? And so for each person, I have the first name, I have the last name, and I have the age, right? So 3 keys in each dictionary. And by the way, I love using lists of dictionaries. I do that all the time, right? So, okay, so can I sort this list of dicts? And the answer is no, not really. Why? Because if I run sorted on people, Python will give me an error. No, less than is not supported between instances of dict and dict. You can't do it. But I can use a key function. So let's say I want to sort by age. I can say def by age, D, return D of age. That's pretty great. That means that we're going to pass each dictionary to by age. That's going to be our key function. And we're going to return the value associated with the H key. So I say print sort of people key by age. Voila. Sorted by age, 1417, 1950. What if I want to sort by multiple keys? I want to sort first by last name and then by first name. Well, I can do that. I'll just have the key function return a tuple because Python knows how to sort tuples. First by index 0, then index 1, then index 2. And here's how I can do it. Def by last first of D, return D of last, and then D of first. I'm returning a tuple. Notice you don't need the parentheses for the tuple. And then I can just say print sort of people key equals by last first. And sure enough, I get people sorted initially by the last name and then by the first name. Pretty snazzy. Now, why write a key function? The whole point is that we're defining this function so that we can sort better. But what if I'm defining it just to use it once? I could do better with lambda, right? Lambda returns a function object. And if I have a function that uses lambda, it's just one expression, but one expression is what I'm generally going to do. So instead of saying key equals by first last, I could just say print sort of people, key equals lambda of d, return the tuple d last, d first. Will this work? Absolutely, positively, it will work. Is it a good idea? I would say increasingly, no. Increasingly, modern Python discourages us from using lambda, in part because people get confused by it, and in part because we have, I think, better alternatives. Here's a more modern Pythonic approach, operator.itemGetter. So it's a function that returns a function. So if I call operator.itemGetter and pass it age, I will get back a function that returns square brackets age. That's exactly what we did before with our by age. So I can now say print sort of people key equals operator.itemGetter age. And that works just fine. But it gets better than that. I know you're thinking, how can it get better? It does get better because we can call with multiple arguments. If I call operator.itemGetter with multiple arguments, it will return a tuple for each element. Right, so we'll return a tuple of last name and first name, just like I did before with my fancy schmancy function, but now I can do it in line with operator.itemGetter. And this is a great way to do things. So itemGetter can take any number of arguments, and it then returns a tuple of that length, retrieving square brackets from the first thing, the second thing, the third thing. What if I have person objects, right? I'm not going to use a list of dictionaries. I have a list of person objects where I created this class, person. And really, it's a simple class where I just say first, last, and age. Well, what if I try to sort them? The answer is it's not going to work. And it's not going to work because, once again, we see that error message, less than is not supported between instances of person and person. But I wanted to, right? So how can I do this? Actually, we can do something inside of our class that will help us out. You could call it a very classy approach. I'm going to implement the less than operator for my class. I'm going to say def of dunder LT. LT is less than. And so now, how do I do that? Well, dunder LT, that's invoked every time we use the less than function. And it's great. But you know what? I can do even better. I can also implement the EQ function. And that's for equal equal. And if I have dunder LT and if I have dunder EQ, we basically have everything we need, almost everything we need for full sorting. And then I can sort it. And look at that. Sorted works and it gives me the right answer. Well, I guess you don't see the answer here, but yes, it does work. But we can do even better than that. What if I want to sort by last and first names? Well, I can do that, right? I just have to change my LT and EQ. Now I'm going to return a list. I can return a list. I can return a tuple. I'm going to say, well, return a list is less than this. LT is getting self and other, right? So LT, if you didn't notice it before, always gets two arguments. It's two parameters, self, the current object, the one on the left, and other, the thing on the right. And so we can say now, don't compare last, don't compare first, just compare the list last first with other last and first. And if I do that for dunder LT, I do that for dunder EQ, now I can sort people and sorted will work just fine. But you know what won't work? This. If I say, is people 1 greater than or equal to people 0? Meaning I'm going to my list people and I'm saying, is this one greater than or equal to that? And it says, no, greater than or equal is not supported. But I implemented less than, and I implemented equal equal. Can Python sort of kind of assume, understand what I want to do? And the answer is no. But we can come really, really close. We can use total ordering. And total ordering is a decorator in the func tools module. And if I say before my class definition, func tools of total ordering goes through our class as, oh, you implemented EQ, you implemented LT, I'll take it from here. And then it implements all of the rest of the comparison operators, LE for less than or equal, GT for greater than, GE for greater than or equal, NE for not equal. It does all of those. And thus, after we've done that, print people 1 greater than equal people 0, return true. It won't give us an error. One last thing I want to show you. As of Python 3.7, so that's been a while already, we can use data classes, and these reduce the code by a lot. And they can also handle sorting. So how do I re-implement my person object using data classes? I say from data classes, import data class. Okay, got to do that. And then I have the data class decorator before my class birthday. Look at that. I'm just going to say firster, laster, agent. Those are going to be my 3 attributes on each instance. And look at this. When I say at data class order equals true, that means I wanted to add all those sorting and comparison operators. So it's going to add dunder EQ, dunder LT, dunder all those different things. Now, here's the other thing. These are my 3 attributes. So each instance of person must have first, last, and age. And that's how they're going to be ordered. So if I say sort of people, I'll get them ordered by first name, then by last name, then by age. The order in which you declare your attributes in a data class, that's the order in which they're going to be sorted. So we need to change the declarations of our attributes if we want to modify the sort order. So if I want to sort first by last name, then by first name, then by age, I just need to declare them last, then first, then age, and then we'll be totally fine. And then we will indeed be sorting by last name, then first name, then age. All good. All right, didn't have to do that. So to summarize, and then I will turn off my screen share so I can see your questions. Hopefully you've got lots of them. Python sorted function lets you sort anything. And the key to this is the key function. Any function or method that takes a single input and returns a sortable output. You could write your own function. You can use lambda. You can though, and I really love to do this, use operator item getter with 1 or more arguments. Classes are sortable if they define some magic methods, at the very least LT and EQ. But if you add total ordering, then you've got even more. And data classes, which I still can't decide if they are the future of Python classes or just sort of an interesting sideshow, but they make it even easier to do that. All right, if you have questions or comments, I'm going to turn off my screen share so I can see what you've got now in the chat. I would love to hear from you after this talk. You can always email me. You can follow me on Twitter at Reuven Lerner. I'm constantly tweeting about Python-related stuff. Don't forget my Better Developers newsletter. Thank you so much for your attention, and let's see what questions you've got. Hopefully tons of them. All right, let's see what we got here.
Yes, thank you, sir. It was like really interesting and worthy. So now the delegates can raise your questions in the Q&A chat, or else you can raise your hand as well, so that you can unmute and clarify any doubts you have. Yeah, let's move to the Q&A questions we have.
Okay.
Yeah, for the first question, we have a bit lengthy question.
Whoa, I was not expecting it to be so fancy. Very impressive.
Yes, for sorting, we have many different methods. For example, bubble sort, insertion sort, selection sort, quick sort, merge sort, etc. When going to the industry, is it essential to know all of these sorting algorithms?
So I'm going to give you my favorite answer, which is yes and no. You will definitely be asked them at some point in a job interview, because job interviews ask lots of annoying questions. So you should know them. At the same time, in your day-to-day work, you likely don't need to know them that well. In your day-to-day work, you're going to be using whatever built-in sorting system is in the language that you're using. So in Python, you're just going to use sorted. You don't need to choose between them. There is one exception to that, I'd say, which is if you're doing data analytics with NumPy or with pandas, there you will sometimes want to choose a different algorithm, and there you can do it. You can explicitly say, I want to use heap sort, quick sort, or tim sort. Oh, I can't tell if I can't hear you, or if are you muted or am I muted?
Yes, sir, right.
All right, fine.
Thank you. And yeah, we have another question. I'd like to know which kind of Python evaluator or examiner available for self-evaluate sort methods.
I don't think there's anything special. I tend to use Jupyter a lot. Like I use Jupyter Notebook for trying things out, for playing with things, for testing things. So I would say try that. Some people like to use a debugger. Some people like to use a REPL. But it's sort of like whatever your style is. I think you should try that.
Yes, thank you again. And which Python sorting algorithm is much needed for data engineering?
So look, I don't know. I typically don't even think about it very much, just because I sort of rely upon Python to do it for me with timsort. You probably, at the end of the day, you probably need to know your data well enough and how it's sorted, how big it is, and do some testing, right? Like do some benchmarking evaluation with it.
Yes, thank you. And we have another question. Wait. What is the best method to sort a big data set in a large file?
Oh, okay. So first of all, people love to talk about big data, and big data is sort of like in the eye of the beholder, right? Some people think, like, what is really big? So if it can fit into memory, then I don't think there's any like one best method, but you do want to avoid, like, if it's too big for memory, then you're sort of in trouble. And I would say if it's too big for memory, then either you need to do some sort of distributed system, which I'm not very like knowledgeable about, or you just want to throw it into a database. And like databases are really good at doing exactly that sort of thing. So I would say, like, if it can fit into memory, just use sorted, and if it cannot fit into memory, then let someone else do it, like outsource it to someone else.
Yes, we have. This question was so frequent in the chat. Once you given a use case scenario, how to identify what's the best sorting algorithm in order to solve it?
I don't have a good answer to that. Again, like I mean, so again, I really fell asleep a little too much in my university algorithms class. I mean, I would say I'm sure there are people who really know this stuff deeply, and then can choose an algorithm up front from just looking at the data. I would tend to go with the default, and if it's not good enough, then start benchmarking, maybe with small subsets of your data, to see which works better. The time it module that comes with Python is really good at doing that sort of simple benchmarking. But I don't think there's any one rule of this one will always be good and this one will always be bad. Well, except for bubble sort, which will always be bad.
Yes, and one more question, like how to calculate sorting complexity in a inbuilt Python sorting algorithm.
Well, okay, so there's the sorting complexity of the algorithm itself, which I honestly don't know. But there's also the complexity of your function. And so I guess one theme that I'm hearing here in all these questions is we want to worry about how efficient our sorting is. And in Python, you don't really have control over the sorting algorithm's efficiency. TimSort is built in, that's what we've got. Where you can improve things, where you should think about things, is your key function. If you are using a specific function, then you want to make sure that's as fast as possible. And so it's less a sorting complexity thing, O of n, O of log n, n log n, that sort of thing. And more like check to make sure that your particular function is running quickly. And it might mean, I doubt it, but it might mean that you need to even like drop down into C or Rust or some other sort of compiled language. Not that I really have ever done that, but that's how you might need to do it in order to improve the efficiency.
Yes, and one more. Is there a built-in method for all those sorting algorithms?
No, not as far as I know. It could be. It could be that in the Python standard library there are other ways to sort. But remember that Python, a huge proportion of Python is implemented in Python itself, right, in the Python standard library. But that's not true for the built-ins. The built-ins, like sorted, are written in C, and they're written in C because it's much faster than Python. What can you do? And so there might be alternative implementations, like NumPy has its own implementation for different sorting algorithms. But in core Python, is there? I really don't know. I really, really don't know. At the end of the day, in Python, you're going to be sorting with the sorted function, and hopefully it's good enough for your purposes. And if it's not, oh well.
Yes, and why we go for manual sorting methods instead of choosing built-in sorting method?
So basically, why would I want to have use a key function to modify how the sorting is done? Because sometimes I want to sort in a different way, right? So to take the example from my slides of sorting a list of people. So if I have a list of people objects, do I want to sort them by age? Do I want to sort them by last name? Do I want to sort them by first name? Do I want to sort them by combination? Rarely is there only one way to sort data. And so I'll want to use my key function in order to sort it in the way that best suits my needs. At the end of the day, right, we want to present the data. We want to use the data. And so how you sort it will have like a big effect on what you show and what insights you get from the data.
Yes, I think we can come to the final question. What is the algorithm used in Python sort function?
So it's known as TimSort. TimSort, and if you look up TimSort in Wikipedia, you'll find a full explanation there, probably more than you ever wanted to know in your life. But basically, that's what we use. Again, if you want to use a different algorithm, I guess you can, but I haven't seen too many people use that outside of NumPy and Pandas. And even there, the default is to use TimSort.
Yes, and that comes to the end of the Q&A session as well. Thank you so much, sir, for sharing your insights and knowledge with the delegates. Yes, and thank you for the active participation of the delegates as well. So we have come to the conclusion of the first session. So thank you for sharing your knowledge and thank you for the participation, and hope to see you in the next session of automating your daily tasks at 11:15. Thank you.